Hello again, this is Dr. Olson from Daytona State College. This is the final video for Chapter 2 on warming the atmosphere. We had our first videos talking about energy and heat, the definition of energy and the different types of heat. Then the next couple of videos we talked about the energy budget, which is simply the balance of incoming and outgoing energy. With that energy budget, we also discussed what happens if there is a misbalance in energy flow. If there's more energy coming in than going out, and there's a net surplus of energy, therefore you have an increase in temperature. This leads very nicely into the final topic of our chapter, which is on seasons. While talking about seasons, really what we're talking about is periods of time where there is a surplus of energy, which we call summer, and periods of time where there's a deficit of energy, which we know as winter. So why does the Earth have seasons in the first place? Well, the seasons come from, as we just said, the differences in the amount of energy that reaches the Earth's surface. And the amount of energy that reaches the Earth's surface can be influenced by three things: the distance of the Earth from the sun, the solar angle, and the length of daylight. Now, the distance from the sun is determined by the Earth's orbit, and so we'll talk about that first, and then we'll talk about the other two as well. When we talk about the Earth's orbit, we make a couple of reiterations, things that everybody knows, but worth mentioning again. The Earth makes a rotation once every 24 hours. The Earth also revolves around the sun and does so every 365 days. Now, most people understand that revolution to be a circular path. Actually, Earth does not revolve in a circular path. It is an elliptical path. And since it's an elliptical path, there will be times where the Earth is closer to the sun and times where the Earth is farther from the sun. Turns out that the Earth is closest to the sun in January and farthest from the sun in July. So what does that mean for us here in the Northern Hemisphere? In January, when we are in our winter months, we are going to be closer to the sun. Since we're closer to the sun, we're going to receive more energy. Therefore, our winter months become not as severe as they could be. Likewise, in July, we're in our summer months, so we get some very direct sunlight coming straight towards us. So there's a lot of heating. But we are farther away from the sun, so sunlight is less intense. Therefore, summer becomes more mild than it could have been otherwise. So here in the Northern Hemisphere, we're grateful for this elliptical path. It actually makes things a little bit more mild. But yes, the distance from the Earth to the sun and that changing distance has a great deal to do with the seasons. The second thing that helps to determine season is the angle of sunlight. Picture a flashlight. You have a flashlight and you're shining it on a tabletop, and you're holding the flashlight directly up so the light is coming straight down. When you do that, you have a very concise circle, and all the light is concentrated in that circle. But if you take that flashlight and tip it so that it's shining at the same spot but at an angle, then your circle of light starts to stretch out. The light has to cover a much larger area, and so you basically share the love. The same amount of light is coming down, but it has to be spread out over a larger area. The sun does the exact same thing. Middle of the day or middle of the summer, the sun has is at a more direct angle. The light is more concentrated in a smaller area. And when you have more direct angles or more concentrated insolation, that means that you're going to have more heating. But late in the evening or in the winter months, the sun is going to be lower on the horizon, so it's going to be more indirect sunlight. The light is spread over a much larger area, and since it's all spread out, there's going to be the sun's going to be less intense, so there's less heating. Now, how does this affect seasons? Well, remember how we said that the Earth revolves around the sun once every 365 days. If we start in the June solstice, the northern hemisphere is tipped towards the sun. And being tipped towards the sun, that means that the sunlight is going to be a little more direct. So we have more intense heating, more intense sunlight, so we have more heating. Therefore, we warm up in the summer. Fast forward 6 months to the December solstice. The North Pole is tipped away from the sun, so the sun is lower on the horizon. You get more indirect sunlight, less intense. Therefore, there is less heating in the winter months. The two time periods in between, March and September, the sun is right in the middle. It becomes actually equal between the north and south hemispheres. Therefore, we call those equinox. And that's what happens then. All right, the final point, which has a lot to do with this rotation of the revolution of the Earth, around the sun, is the length of daylight. Now, imagine you're at the pole, and the pole is pointed towards the sun. I'm going to zoom in here a little bit. There we go. The North Pole is pointed towards the sun. Well, since it's pointed towards the sun, there will be a region right around the pole where it's continually in sunlight. So those regions get 24 hours of daylight. The sun never sets in that region. And in some places, it never sets for months, such as at the North Pole. The sun stays up above the horizon for 6 months of the year. The opposite pole, the winter pole, in this case the southern pole, when it's tipped away from the sun, sunlight comes and ends right about here. This region at the South Pole is in perpetual night, 24 hours of nighttime, 4 months on end. At the pole itself, 6 months of nighttime. So as you go from the winter pole to the southern sunlit pole, so say that again, I apologize. Go from the winter pole to the summer pole. Notice that the amount of daylight increases. And that has to do with how much of the hemisphere is actually covered with sunlight at a time. The equator will always have 12 hours of sunlight, whether it's winter, summer, or spring or fall. It will always have 12 hours of sunlight, and it's just the poles that will vary and the mid-latitudes in between. Well, what does that mean for heating? Well, when you have more daylight, that means that you have more sunlight that can come in and heat it up, so more daylight will equate to more heating. And the closer you get to the pole, the more daylight hours you have, so the more heating you have. This really is the key to why we have summers. As we go closer to the sunward pole, more daylight hours, so there's more heating, therefore it's going to get a lot hotter. Whereas if we go to the opposite pole, the nighttime pole, then there will be less daylight, so we're going to have a lack of incoming radiation, therefore it gets colder, you get more nighttime hours, it becomes more of a winter season then. This figure is a cool figure that shows what the path of the sun would be at different latitudes based on the time of the year. At the North Pole, what you would see at the June solstice is you would just see the sun in the sky just spinning circles 24 hours a day. And then as you get towards the September equinox, that circle will just fall to a lower point in the sky until the equinox, when the sun is just skirting the horizon for 24 hours. After the equinox, the sun will set and then will stay set and not rise again for 6 months until the March equinox. At the Arctic Circle, you have a similar pattern. June solstice, the sun will do a circle for 24 hours a day, but that circle is at an angle so that right at midnight, the sun will touch the horizon but come right back up. Equinox, you will have 12 hours of sunlight. December solstice, the sun will be set for 24 hours a day until noon, when the sun will poke up and set immediately after. Then as you go from mid-latitudes to the tropics to the equator, the sun just gets higher and higher and higher in the sky until at the equator, the sun is directly overhead. Then as you go into the southern hemisphere, you get the exact same patterns, just the opposite side of the sky. So the sun starts appearing in the north half of the sky. And that completes everything from Chapter 2. Feel free to go through it again if you need to. If you have any questions, email me, call me, whatever you need to. I will be more than happy to answer whatever questions you have. The next videos will cover the next chapter, Chapter 3, which deals with daily air temperatures. So until then, have a good night, a good day, and we will see you then.